Hello everyone, today in this video we'll be discussing the second module of POP, which is Principles of Programming Language using C. And here we have three topics: operators, decision control, and looping statements. And if you watch this video till the end, easily you can score more than 80% marks in the exam. Make sure hit the like button, subscribe to my channel, that helps me make more videos like this. Without wasting any more time, let's get started. The first is operators in C. So what is an operator? Here in A plus B, plus is an operator. Okay, and A and B are the operands. Okay, so this is the concept behind the operators and the operands, and there are different types of operators. Okay, like we have arithmetic operator, relational operator, equality, and so on. Each of them will be discussing using an example. Okay, so the first one, what is an arithmetic operator? Okay, arithmetic operator is used to perform the arithmetic operations. Okay, so what all the arithmetic operations we perform usually? The arithmetic operations we perform are the subtraction, multiplication, division. Okay, this is the multiplication, division, addition, subtraction, and modulus. All these are the operators which are being performed, and here is the syntax is given. Okay, and the result will be as follows for each of these. If a is equal to 9 and b is equal to 3, the following will be the result. Okay, so the operator which performs these operations, that is called as the arithmetic operator. Okay, so the arithmetic operator can be either of these five. Next one is the relational operator. In relational operator, it is used to compare the two values. So here, less than, greater than, less than or equal to, greater than or equal to, and 3 less than 5, what it will give? 3 less than 5, is it true or false? The answer is true. Why? Because 3 is less than 5, so it will give 1. 1 means true and 0 means false. Is 7 greater than 9? No, it is not, so it gives 0. Is 100 less than or equal to 100? Yes, it is. Is 50 greater than or equal to 100? No, it is not, so it will give 0. Okay, so the relational operator will do the comparisons. Okay, next we have the equality operator. In equality operator, two values are being checked. Okay, here we'll use double equal to. So two values, if they are equal, both are equal, like for example, if I put a double equal to b, if a and b's values are same, it will return 1, else it will return 0. Here it is not equal to. If both values are not equal, it will return 1, and if it is equal, it will return as 0. Moving on, we have the logical operator. It also does the comparison, but here we use different types of symbols. Here we use logical and logical or and logical not. So these things are used for the binary values. For suppose a and b, here the values are given here for zeros and ones. A and b can be 0 0 0 1 1 0 1 1. So a and b, that will be 0. If both are 0, it will be 0. If one of them is also 0, and operation will give me 0. One of them is 0, here it will give 0. If both of them are 1, then only I will get as 1. That is the AND operation. In the OR operation, either of them should be 1, then only we will get as 1. So here it is 0 because either of them is not 1. Here either of them is 1. Here also either of them is 1. And here both of them are 1. So it will obviously be 1 only. Not will do the ulta of it. Okay, so if A is 0, it will become 1. If A is 1, it will become 0. And here we use the exclamatory mark. Moving on, we have the unary operator. Unary means single operator. Means here we'll be having a single operand. In this all cases, we had two operands, right? In addition, subtraction, relative, all those we had two operands. Here we'll have one operand only. Okay. So the example is unary minus. So a is equal to, if you put a unary minus here before b, the negative value of b will be calculated and it will be taken into consideration. So if b is equal to 5, what will be minus b? It will be minus 5. So a will be assigned as minus 5 if you do a is equal to minus b. Okay, that is a unary minus. Increment operator, it will increment the value. C is here, c++ will make c's value increment by 1. Here also two things are there. This is post fix and this is prefix increment. Okay, so post fix increment, what it will do is, first it will take the value and then it will increment. Okay, first it will take the value, then it will increment. That means if c is equal to 6, okay, c's value is 6, I am doing c is equal to c++. So what will happen? 6 will go here, c's value will remain 6, but in the next iteration c's value will become 7. Okay, like that. And plus plus c, first it will increment the c value. So here what will happen, if I do c is equal to plus plus c, what will happen? First c will become c plus 1, which is equal to 6 plus 1 is equal to 7. First c will become 7 and that 7 will be assigned to c. Okay, so it is like first you need to take the value or first you need to increment the value. That thing is specified by prefix or postfix incrementer. Same thing goes for the decrement also. Subtracted one value here and subtracted one value and taken the value, and taken the value then subtracted the value from here. Okay, that is a unary operator. Only single operand is there, so it is called as unary. Next is the conditional operator. In conditional operator, we have three values. Okay, exponent 1, exponent 2, and expression 3. This is expression. Okay, expression 1 question mark, expression 2 or expression 3. Here what will happen is expression 1 will be there, and if expression 1 can give two values, either it will be true or it will be false. If it is true, this will be taken. If it is false, this will be taken. Listen again. Here there will be an expression whose value can be either true or false. If it is true, this will be taken. If it is false, this will be taken. Let's take an example. Age greater than or equal to 18. If it is age value, whatever it is stored, if it is greater than or equal to 18, the printf will happen eligible to vote. Else, if it is less than 18, it will happen printf not eligible to vote, like that. Which one should execute, that depends on the truth value of this one. Okay, that is called as conditional operator. We have bitwise operator. Bitwise is also same as the previous one, which is a logical operator, but here we'll be using just single ones. Okay, like single and here, and single or, and single not here, and single XOR here. So for the single operators also it's the same thing, but the technically it will be different. Okay, like for example, if I do a and b, okay, what will happen if a is equal to 1 and b will be equal to 0, a and b will happen, that will become 0. Okay, it's very similar, but slight differences are there, so you need not go into the depth. Just understand that bitwise operator will have a single values here, like single and or and all. And bitwise left shift, bitwise right shift. Left shift means add 1 0 here. Okay, if this is the number, okay, add 1 0 at the end. So what will happen, if you add 1 0 at the end, this 0 will get removed, and this value which is there, that is equivalent to this value. Okay, got my point. Just add 1 0 here and remove 1 0 from here. That is the left shift. Right shift means you are adding 1 0 here and removing this from here. Okay, so if you add 1 0 here, it will be 0 0 0 0, that is 0 0 0 0, and this is triple 1 0, so this is triple 1 0. Okay, so this is the bitwise right shift operator. Okay, moving on, we have the assignment operator. So what does assignment operator do? Okay, it is responsible for assigning the value to the variables. So if a is there, if I want to assign some value is equal to 7, so this is used to assign the value. Okay, so this is called as assignment operator. Along with the assignment operator, we can have shortcuts also, like divide equal to, multiply equal to, plus equal to, and so on. So what does these values do? For example, if I have a, if I do plus is equal to 2, that is equivalent to writing a is equal to a plus 2. Okay, these both are equal. Okay, you got my point. For writing in a shortcut, we will be writing plus equal to, that is equal, this thing is equivalent to a is equal to a plus 2, like that. Okay, that is a shortcut we use. We can use that shortcut with division operator, multiplication, addition, subtraction, ampersand, and this is the XOR operator, and this is the right shift and the left shift operator. So okay, so that is the assignment operator. Moving on, we have the comma operator. In the comma operator, it takes the two operands. This will be calculated first, then this will be calculated, and whatever the value we get here, that will be assigned to x. That is the comma operator. Next, we have this size of operator. In size of operator, we will find the size of the variable. Okay, what is the size of the variable? So int will have some size, float will have some size, char will have some size. For example, int size is 2, float size is 4, char size is 1. So to find out the size, actual size, will be doing like this. Since any number is printed here, we'll be doing percentage d, size of a, size of b, size of c. A is the integer value, b is the float value, and c is the char value. Okay, so this is the size of operator. Find out the size of the variable. Moving on, we have the very important question from the exam point of view: the type conversion and the type casting. Type conversion, this is done implicitly, means it the computer will lead us. So here's an example. Let's take float x. Okay, so x will store a decimal value. Then we will take int y is equal to 3. So y has 3 value. And if you do like this, x is equal to y. So float's value is going inside integer value. So the integer should become float here. It will be upgraded to float. Okay, int will become upgraded to float, so it will be x will be 3.0, like that. Okay, so this is the example of type conversion. It implicitly happens. Now suppose we want to do it on our own manually. If you want to do, that is called as typecasting. That is a forceful conversion of the data type into another data type. Suppose that float salary is there 100.00, int salary we have taken here, int sal. Now sal is equal to, if you put int here, this salary will be converted to integer value, and that will be stored in sal. Okay, so that is called as the typecasting. Okay, moving on to the second topic of the module 2, which is decision control statements. Very easy topic. Let's have a look with the examples. Decision control statements can be used to alter the flow of the instructions. Okay, so a point comes where the value can be either true or it can be false or any other value, like third option. Okay, so in that case, we can change the sequence of the flow, like it can go here or it can go here. Okay, in that case, we'll be using the decision control statement. So if I take an example, it will be more clear. There are four types of such statements: if else, if else if, and switch. Okay, so let's have a look at each one by one. If statement. So Here's the question: write a program to determine whether a person is eligible to vote or not. Okay, so we'll be using the stdio and void main here, and age we will be taking. Inside the age we will be taking the age, and after taking the age we'll be comparing here. If age is greater than or equal to 18, whatever age we have entered, if that value is greater than or equal to 18, then this will happen. Whatever is between these two brackets, that will happen, which is print if he or she is eligible to vote. Okay, if it is not the case, we will not get any printed here, because only when this is true, then only what will be executed inside this will be executed. Okay, if it is not, it will not get executed. That is for the if condition. Okay, here write a program to determine a character entered by the user. Okay, determine the character. We have to determine if it is a character or not. It can be either number, it can be a symbol, and it can be even blank space. So we have to determine if it's a character or not. So in this case, we'll take a character ch, take the character from the user, and we'll check if character is greater than 0. If it's a character, it will be greater than 0. If it is a number or a symbol, it will be less than 0. Okay, so if it is greater than 0, it will print f as the character has been entered. Okay. Next we have if else statement. So till now we just considered if something is there, something should happen. But what if this does not happen? Something else should happen, right? So that else will be executed. Okay. So here write a program to find if a given number is even or odd. Okay. So even numbers are the ones which, when divided by 2 or take modulus of 2, remainder will be 0. Okay. If it is not even number, the remainder will be 1. Okay. So using that, we'll be checking here. Enter the number, take the number here. A modulus 2 equal to 0. If it is 0, means if the number is even, the remainder is 0, the number is even. And if the remainder is not 0, else will be executed. This will be executed with the printf, the number is odd. Okay. So if a's value is 5, the remainder will be 1. So this will be false. When this is false, this will not get executed, but else part will get executed between these two braces. Okay. So printf number is odd will be printed. On the other hand, if it is a true value, this will get executed and else will not get executed. Okay. So only with the what printed will be there, the number is even. Okay. Another example, write a program to find the largest of two numbers. Two numbers are there, find the largest one. Okay. So here a is equal to 100, b is equal to 20. If a is less than b, is a less than b? No, it's not. So this will not be printed, but this will be printed. Okay. Next we have if else if statement. So what if we are considering a is less than b, a is greater than b, and what if a is equal to b? If that case comes, we have to have another if condition, right? If a equal to b. In that case, if it's more than two conditions, we'll be using if else if statement. So let's take an example. Here we are taking a and b, and the value of a and b is taken here. If a is equal to b, a and b are equal. Else if a is greater than b, a is greater than b will be printed. Else if it's not both of these cases, obviously the case is a is less than b, so therefore a is less than b will be printed. Okay. Next we have a similar question. Write a program to check if the number is positive, negative, or equal to 0. Here we'll take the number from the user, scan f the statement, and then if a is greater than 0, a is positive. If a is less than 0, it is negative. Else the number is equal to 0. If it is not greater than 0, if it is not less than 0 also, obviously the number is 0 itself. Okay, so this will be printed. This is how you use the if else if conditions. The last one we have this switch statement. Okay, in switch statement will be more than two, three, four, how many ever you want, multi-way decision statement. Okay, it will be having more than one. Okay, so here char grade we have taken c. So grade is a variable which is storing the value c here. Now what we write is switch grade. The grade we are passing here inside the switch, and whatever the value of grade is, whatever the number is, if it is matching here, case a is the case, whatever I have passed in the grade, is it equal to a? If that's the case, this will be taken into consideration. If it is b, this will be taken. If it is c, this will be taken. Default means if neither of these case works, this should be printed. Okay, and after each statement you have to write break. Break means once this is executed, just break out of the switch statement. Why? Because if you don't write break, obviously the next also will be executed without comparing this one. Okay, so this is how the c language is. Once the comparison is done, again it will not happen. And if you don't put break, this will be printed, then this will be printed, this will be printed, and default will also be printed. So we need to add break always. Okay, so this is a switch statement. Another example, checking the day of the week. Okay, so for example, if I take in day, enter any number from 1 to 7. So I'll take one variable here, number here inside day, and if it is if the value of day is 1, it should print Sunday. If it is 2, it should print Monday. If it is 3, it should print Tuesday, and so on. Okay, whatever is the day, it should print. If I enter any value more than 1 to 7, in between 1 to 7, if I enter like suppose I enter 8, then default will be printed, because you have entered the wrong number. Okay, so this will be printed if any number comes which does not match any of these cases. Okay, that's why I use default here. Okay, Moving to the last topic, which is the iterative statements. Okay, iterative means what? Repetitive. Okay, there are three types of repetitive statements or iterative statements: while loop, do while loop, and for loop. Okay, so let's understand what it means. While loop. Okay, write a program to calculate the sum of first 10 numbers. Okay, so what does it mean? 1 plus 2 plus 3 plus 4 till first 10 number means till 10. Okay, so here we will take integer I is equal to 1, sum is equal to 0, while I is less than or equal to 10. This is the condition we are checking. Okay, see, we are writing while here. After that, inside the bracket we are passing one condition: i's value, whatever it is there, is it less than or equal to 10? If this is true, then only whatever is between this and this will be executed. Between the braces, whatever is there will execute only when this condition is true. So this condition will be true until and unless it crosses 10 and becomes 11. Okay, till 10 it will be true, so it will always be printing, I mean doing this whatever is in between these two. Okay, so here sum is equal to sum plus I. So sum will be initially 0, then I will be 1 here. So sum will be 0 plus 1, sum will be 1. I will become 2 here, I plus plus. Okay, I will become 2. When I will become 2, here sum is 1, then 2 will be added. So 1 plus 2, 3 will be stored. Then here 3 will be added. 3 plus 3, 6. Then 4 will be added. 4 plus 3, 7. Like that it will keep on adding. Okay, so it will keep on adding and sum will be finally printed here. This is how you use the while loop. Okay, yeah, if you want to do it until some condition, and write a program to print 20 horizontal asterisks, means 20 stars you have to print, like this: 1 star, 2 star, 3 star, 20 stars you have to print. So we can use a while loop here. Why I is equal to 1 we have taken, condition is I should be less than or equal to 20. Till that point, print f star, then do I plus plus. So it will do 20 times and it will exit the loop. When this becomes false, it will break out of this loop here and it will come and do the next part. Okay, we can have the do while loop also. Okay, so do while loop and while loop are very similar, except that do while will first do the loop. Okay, do it once, then it will check. Okay, so here float average is there, int I and n we have taken, sum is also taken here. Enter the value of n. You have to calculate the average of first n numbers. Okay, so do what we are doing here. First this will execute no matter the condition. Okay, it will obviously execute sum plus is equal to I plus plus will happen. Then it will check whether it should execute for the next iteration or not. That is the only difference. Do will execute at least once. Okay, at least once it will execute, but while loop will never execute unless the condition is true. Even if this condition is false, it will execute one time, then it will check. Okay, but in while condition we cannot use that. Okay, so it has on its own use cases where we what will happen is the it will be required for at least one time execution. Okay, in that cases we use, then we'll calculate the average here and print the sum and the average as well. Okay, third is the for loop. Okay, so write a program to print n whole numbers. Okay, you have to print n whole numbers, the first n numbers. Okay, so enter the value of n we are taking, and after that we are starting from I is equal to 0. See, this is the syntax for the for loop. Okay, we'll write for here and we'll open a bracket and write three things: first thing, second thing, and third thing. First thing is I is equal to 0. Which variable you are using and what is its initial value? Which variable you are using and what is its initial value will be specified here. That's the first argument. Second argument is argument of the parameters. This is called as the parameters here, and here we will be using I less than or equal to n. This is the condition which will be checked. Okay, I have entered one value, and whether I should execute this loop or not, it will be dependent on this condition: is I less than or equal to n. N value is what? If I have taken 15 and I is 0, obviously 0 is less than 15, I is less than n, and this will execute. Whenever this is done, we'll just come here. Okay, we'll not do this, we'll come here, we'll do this operation. After this operation is over, it will go here and do this one. This is the incremental part, means i's value should change. I value is changing at this point. Okay, so this is what happens in the for loop. First I is 0, printf I, then it will go I plus plus, then I will be 1, printf I, and each time it will be checking if it is less than n. After it is more than n, this will not execute and it will come out of the loop. Okay, this is how the for loop works. Okay, another example is write a program to print the multiples of 4 until 40. What are the multiples of 4? 4, 8, 12, 16. Observe one thing, we are adding 4 always, right? That is the multiples, that is how we get the multiples. So here we'll take int I and n, enter the value of n, we're taking the value of n. Suppose that n's value is equal to 40. Okay, so here it will be I is equal to 4, the initial value of I is 4. If this will be checked, I is less than or equal to n, which is I is less than or equal to 40. Obviously 4 is less than 40, so this will be executed and this will be printed here. After that we'll go here, and here what is happening, I plus is equal to 4. What does I plus equal to 4 mean? I is equal to I plus 4. Okay, this is what it means, both are equal. Okay, so I is equal to I plus 4. I plus 4 means 4 plus 4 8. So I's value will become 8 and this will execute, and this will be checked, is 8 less than 40? Yes. Then again it will happen here, I plus equal to 4, 8 plus 4 12, 12 less than 40? Yes, print. Like that it will keep on going until it is 40, it will print here. After that it will become 40 plus 4, 44. Is 44 less than 40? No, it is not. 44 is less than 40? No, it is not. So this will not execute. Okay, when this will not execute, it will come out of this loop. This is called as a for loop. Okay, this is used when we want to print it n number of times. Means we want to do this operation n number of times. There is a specific here. But if we want to execute based on a condition, we will be using while loop. Okay. Next is the nested for loop. In nested for loop, we will be having a for loop inside another for loop. For example, write a program to print the following pattern. So this is a pattern here: 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. So here first we will be using one for loop to print these lines. Okay. First line, second line, third line, fourth line, and fifth line. Next here, the void main, we will be this is how we will write the program. For nested for loop, you have to use two variables I and j. Okay. So this is the outer for loop. I is equal to 1. I is less than or equal to 5. Okay. Is I is 1 means it will check is I is less than or equal to 5. Why you have taken 5? Because we want to print it 5 times. Okay. Then for j is equal to 1, j is less than or equal to I, j plus plus. J is equal to 1, it's starting from, and j is less than or equal to I till I it should go. Okay. And printf j. So here what's happening? In the first iteration, I will be 1. Okay. And j will be 1. And j is less than 1, less than or equal to 1. Yes, it is printf j. So 1 will be printed here. Okay. After that, what will happen? J plus plus. J will become 2. This will be checked. Is j, which is 2, 2 is less than or equal to 1? No, it is not. So this will stop execution. And then once this is stopped execution, it will execute the next code, which is inside the outer for loop, printf slash n. Slash n means a new line will be printed here, so the execution will start from the new line. And then again it will go here. After this is also done, it will go here and update the value of I. So now I will become 2. When I will become 2, this will be checked. Is 2 is less than or equal to 5? Yes, it is. So it will come back again here, and again j will be initialized as 1. J is less than or equal to 2. In this case, now I is 2. J is equal to 1. 1 is less than 2. Yes. So printf j. So j's value will be printed here as 1. Okay. Then j plus plus will happen. Is 2 less than or equal to 2? Yes, 2 is less than or equal to 2. So again j will be executed here and 2 will be printed. So this is how this 2 gets printed. After that, j will become 3. 3 is less than or equal to 2? No, it's not. So this will be stop the execution and will come here, printf the next line. So in next line will be coming like that. 3 times this will be printed, this will be printed 4 times, and this will be printed 5 times. After this fifth time, what will happen? I's value will become 6. Okay, I's value will become 6 and it will be compared 6 less than or equal to 5. No, it's not. So this will not be executed and it will come out of the loop. So this is the how you use the nested for loop to print the following pattern. Okay. Moving on, we have the break statement. What does break mean? Break means we are stopping the execution. Okay. If there is a loop, we are stopping the loop at that point. Print the numbers from 1 to 20. If 12 comes in between, the loop should break. Okay, I did not get a better example. So obviously 12 will come in between. So whenever 12 comes, it should stop the execution. So I'm taking a for loop here. Int I is equal to 1. It's starting from 1. It's being checked. I is less than or equal to 20. I plus plus. Okay. So I is less than 20. Yes, it is. 1 is less than 20. If I equal to 12, this will be compared first. This is not true. 1 is not equal to 12. It will if it is true, it will break, else it will printf I. So first 1 will be printed, then it will go here, it will increment the I value. 2 is less than 20. Yes, it is 2 equal to 12? No, it's not. So it will print it. So it will be 2 here printed, then 3, 4, 5, 6, 7, 8, 9, 10, 11. Till 11 it will be printed. Then it will come here. It will do I plus plus. It will become 12. 12 less than or equal to 20. Yes, it is. So it will come here and it will check 12 equal to 12. Yes, it is. So it will break. Break means stop the whole for loop and come out of it. Okay, that's what break is. So this will not be executed because at this point it is break means it come out of the loop here. So it will be the output only till 11. Okay, this is called as a break statement. Based on some condition, break is there means it will come out of this for loop. Okay, like that only continue statement is there. Here it skips that specific iteration, and unlike the break where the loop execution stops, in the continue what happens, the same example I will take. In continue what happens, till 12 it will come, and if I equal to 12, what will happen? I have written continue here. In continue, the remaining steps will be skipped. Okay, it will be skipped, but the loop will not break. Okay, it will not come out of the loop. The rest of the steps will be skipped and it will do I plus plus. It will become 13 and it will continue from 13. Okay, 13 will be checked and it will be not true. It will come here, printf 13, then 14, then 15, 16, 17, 18, 19. When it is 20, it will be printing 20. When it is 21, this condition will fail and this will come out of the loop. So here only 12 is skipped in between. As you can see here, there is no 12. After 12, the other execution means still continues. Okay, it will not stop, like how in the break it got stopped because it came out of the loop. Here it does not come out of the loop, just that particular statement will be skipped. That is how the continuous statement works. The last one is the go to statement. Go to is used to transfer the control to a specific label. Okay, we are jumping from one point to another point using go to label. Let's understand this using an example. Here in num is equal to, we have taken sum is equal to 0. Okay, two variables num and sum, and we are putting a label here. Okay, this label is the read label. Printf, enter the number and enter 999 to end, and here we'll be taking the number. The number can either be a normal number or it can be a 999. Okay, so we are checking if num is not equal to 999. Whatever num you have taken, if it is not equal to 999, suppose it is 888. Okay, it is not equal, so this will become true because this condition is true. The number is not equal to 999, then it will come inside this and execute this one. Okay, if it is 999 means what will happen, it will come here and it will, this if condition will not be executed, some of the numbers will be entered as 0. Okay, because 999 it will end means it should not execute this one and it will come here. Okay, in case it is 999, what is happening, we are coming here. If num is less than 0, we are first checking if num is less than 0 means you have taken -1 or something, so it will go to read. So what read means, again the execution will start from here. Again it will go here, printf scanf, again the number will be taken. If it is not 999, it will take. If it is less than 0, if it is less than 0, it will again go to read. If it's not, it will do sum plus is equal to num. If the number is 7, sum plus is equal to number means sum is equal to sum plus number. What is sum? Sum is 0, number is 7. 0 plus 7 will happen, it will be stored in sum. So sum will be 7 here. And then again go to read to take the next number. Go to read means it will come here again, printf scanf. If so, like that it continues until we put 999, so that we will come out of this if condition and we will be printing the sum. Okay, so this is how go to statement works. We will be, whenever we go to encounter go to, our label will be there. From that label the execution will be taken from there. Okay, so that is what is called the go to statement. Okay, that's all for this video, and if you found this video helpful, make sure you hit the like button, subscribe to my channel for more videos like this. Thank you so much for watching. I'll see you in the next one.